Hello everyone, myself Mallikarjun of 3D department from St. Peter's Engineering College. Today's our topic is about potentiometers and standardization of potentiometer and also types of potentiometers. Potentiometers, standardization of potentiometer and types of potentiometers. So the first topic what we are going to discuss here in this video is regarding potentiometers. Is regarding what? Potentiometers. The potentiometers are mainly used to measure the unknown EMF of a cell. Mainly used to measure what? Unknown EMF of a cell. The potentiometers are mainly used to measure unknown EMF of a cell. This is the first thing. And the potentiometer can also be used to compare. Potentiometers can also be used to compare unknown EMF. Compare unknown EMF with standard cell. With standard cell. What is the first point? The first point is it is used to measure the unknown EMF of a cell, or else it can also be used to compare the unknown EMF with the standard cell voltage. It has also one more use. It can also be used to measure internal resistance. It can also be used to measure internal resistance. What is the basic purpose of having a potentiometer? It is mainly used to measure the unknown EMF of a cell, or else it can also be used to compare the unknown EMF with the standard cell voltage, or else it can also be used to measure the internal resistance of a cell. Internal resistance of a cell. These three are the main functions of a potentiometer. These three are the main functions of a potentiometer. Now we will go with the construction and working of an potentiometer. Construction and working of an potentiometer. So before going to discuss about the working, we will go with the constructional details. We will go with the constructional details. Constructional details. Now coming to the first point here. For the construction of a potentiometer, I need a wire. I need a long wire, that is long resistive wire. Long resistive wire. Let the length of this wire will be L. Let the length of this wire be L, which can be considered as A and B. So coming to the construction of a potentiometer, the first point what I have considered is nothing but I am taking a long resistance wire whose length is taken as L, and this wire is made between the points A and B. Now I am going to use one more component, that is nothing but a battery. That is nothing but a battery, where the value of this battery is nothing but voltage E with an internal resistance R. With an internal resistance R, which is connected to a rheostat. Which is connected to a rheostat, which is named as RH. Which is named as RH. These are the three basic components, and the combination of these three basic components is considered as what? Primary circuit. Is considered as what? Primary circuit. Primary circuit. The primary circuit is a combination of what? A long resistance wire, a battery whose EMF is to be measured, and also a rheostat. Rheostat is nothing but a variable resistance. A variable resistance. Now I am going to form one more circuit. I am going to form one more circuit with the help of an standard cell voltage, that is nothing but capital E, which is represented as standard cell, which is represented as standard cell, where the other end of the standard cell is connected to a galvanometer, is connected to a galvanometer, where the end of the galvanometer is connected to a resistive wire. Where the end of the galvanometer is connected to a resistive wire. This wire is called as a slide wire. This wire is called as what? Slide wire. Let us say that the wire which is coming from the galvanometer is connected to a long resistive wire at some point J. At some point J. The circuit which is formed between the wire, battery, that is standard cell, and galvanometer is considered as a secondary circuit. Is considered as a secondary circuit, and let me say that the current flowing in the primary circuit is taken as some I. Is taken as some I. This is the construction of a potentiometer, where it consists of a long resistive wire of length L, consists of a battery whose EMF is to be measured, which has an internal resistance R, and it also has a what? Rheostat, that is nothing but a variable resistance, along with a standard cell and galvanometer. These are the important components and also the construction of an potentiometer here. Now we will see the working. That is how this potentiometer is used to measure the unknown EMF, or else it is used to compare the unknown EMF with the standard cell voltage. Now, coming to them, now we have two circuits. When I am constructing a potentiometer, it has formed two circuits. The first circuit is considered as primary circuit, and the second circuit is considered as what? Secondary circuit. Now, let me write the expression for current. In case of a primary circuit, which is represented as I equal to E by RH plus, as it is a resistance, the resistance offered by this length of the wire is considered as R, plus the internal resistance of a battery. The current which is obtained in the primary circuit is given as voltage by, that is E by RH, that is nothing but resistance offered by the rheostat, R resistance offered by the wire, small r internal resistance of a battery, or is internal resistance of the source where I need to measure the value of voltage. This is the expression what is obtained from the primary circuit. Hence it is called as primary current. Or else it can also be called as a working current. Let me name this as equation number 1. So before going to discuss about the potentiometer and also the standardization of a potentiometer, you need to have some properties. That is properties of a potentiometer. The first property is the specific resistance of a potentiometer should be high. What is the first property? The specific resistance offered by the potentiometer should be very high. Coming to the second property, it should be low temperature coefficient. The first property of potentiometer is it should have high specific resistance, and the second property is it should have low temperature coefficient. And coming to the third property, potential gradient. The potential gradient offered by the potentiometer should be also high. These are the three basic properties of our potentiometer. First point is regarding specific resistance, second point is regarding temperature coefficient, and the third point is regarding potential gradient. And the third point is regarding what? Potential gradient. Here the value of potential gradient will play a major role in determining the EMF of a cell. in determining the EMF of a cell. Now we will have an expression for potential gradient. Let me say that let X is a parameter which is used to represent the potential gradient of a potentiometer here. In general, the potential gradient is defined as potential difference per unit length. Potential difference per unit length, where length is represented in meter and voltage is represented in terms of what? Volts. This is the general expression for potential gradient of a potentiometer, which is represented as voltage per unit length. Now we know that what is the current flowing in case of a primary circuit, or what is the expression for working current? E by Rs plus R plus R. Now if I want to derive the expression for potential gradient of a potentiometer, as it plays a major role in determining the unknown EMF, I need to calculate the value of voltage here. I need to calculate the value of voltage here. From the above expression, that is according to Ohm's law, I can write the expression for current as what? V equal to I into R. I know the value of current. What is the expression for current? RH plus R into R. This is the expression for voltage. This is the expression for voltage. Now let me substitute this equation number 2. Let me consider this as equation number 3. Now substituting equation number 2 in equation number 3. What is the equation I will get? E by RH plus R into R by L. This is the final expression for potential gradient what I have obtained by substituting the value of voltage. What is the expression here? X equal to E by RH plus R into what? R by L. The same expression it can also be written as what? It can also be written as I into R by L. Why? Because the total E by this parameter can be written as what? I from equation number 1. So it can also be written as what? I into R by L. If I want to write the same expression in terms of a specific resistance, this equation is termed as what? I into rho by A. How I got this expression in terms of specific resistance here? Why? Because since R equal to rho by L by A, this is the general formula of calculating the resistance in terms of a specific resistance. That is R equal to rho L by A. Now from equation number 4, how can you relate all the parameters with the potential gradient? That is the potential gradient of a potentiometer. If I want to calculate the unknown EMF of a cell by using this potential gradient depends upon what are the parameters. First one is R by L. If the value of resistance per unit length changes, potential gradient changes, then I need to calculate the value of what? Unknown EMF. And the potential gradient is also depends upon what? Specific resistance. It also depends upon specific resistance. It also depends upon current. These are the three parameters. So the potential gradient of a potentiometer will depend upon these three major parameters. First one is resistance per length, second one is specific resistance, and the third one is nothing but current which is flowing in the circuit. This is how to measure an unknown EMF or potential gradient or its other parameters by using a potentiometer here. Now, what is the general reason of having a potentiometer? It is used to measure the unknown EMF, or else it is used to compare the unknown EMF with a standard cell, or else the same potentiometer can also be used to measure the internal resistance of a cell. Now we have come across the construction and also the working and also the expression for potential gradient, current flowing, and also the voltage in case of a potentiometer. in case of an potentiometer. And the galvanometer, which is used in case of a potentiometer, is mainly used for the standardization. Now, what is the meaning of standardization? Here, the standardization of potentiometer is done in order to calculate the unknown EMF by comparing with the standard cell. So we have seen a diagram of a potentiometer where it consists of a standard cell which is represented with an S, and what is the EMF I need to measure? I need to measure the EMF E. So by comparing this unknown EMF with the standard cell voltage, I am going to get the reading. I am going to calculate the unknown EMF by comparing this EMF with the standard cell voltage. If the standard cell voltage is 1.016 volts and I want to measure this unknown EMF by comparing with this standard cell voltage here, with standard cell voltage. So that is the reason, with the help of a galvanometer, I am using slide wire to keep some point on the resistance, that is resistance wire. Now, the potential gradient of the point on a resistance wire with the help of a slide wire will be given as some x equal to V by L into some E, where the value of E is given as what? E by L, where the value of E is given as what? L into some x. So if I want to calculate the potential difference, with the help of a position of a slide wire on that particular resistance wire, I need to calculate by using this formula. Now I can rewrite the expression as what? As we know that x is V by L. V by L into L. V by L into L. What is the reason to have the expression for the voltage? What is the reason for having an expression for voltage obtained with the help of a position of a slide wire is that to know the position of a galvanometer. If the voltage obtained is greater than the unknown EMF or EMF which is going to be measured, then galvanometer will show the deflection in one direction. It will show if the value of V, that is potential difference obtained due to the slide wire, is greater than the EMF measured, then the galvanometer will show the deflection in one direction. If voltage is less than E, galvanometer will show the deflection in opposite direction. If V equal to E, that is whenever the unknown EMF is equal to standard cell voltage, then the galvanometer will show null deflection. Whenever the galvanometer shows the null deflection, then I can say that the potentiometer is standardized. So standardization of potentiometer is mainly based upon the unknown EMF and also the position of a galvanometer. These are the parameters what we have discussed regarding potentiometer, its construction, working, and also the expressions for current, voltage, and potential gradient in case of a potentiometer. Now we will discuss about types of potentiometers. So basically, depending upon the supply, the potentiometers are classified into two types. The first one is DC potentiometer. DC potentiometer. And the second one is AC potentiometer. First one is DC potentiometer and the second one is AC potentiometer. Now we will discuss about DC potentiometer. This DC potentiometer is also called as DC CROMPTON potentiometer. This DC potentiometer is also called as what? DC CROMPTON potentiometer. DC CROMPTON potentiometer. Now we will have the discussion regarding for DC potentiometer is used to measure what values and what is the construction of a DC potentiometer, how it will work, how the standardization of DC potentiometer is to be done. These are the things what we are going to discuss regarding DC CROMPTON potentiometer. DC CROMPTON potentiometer. The DC CROMPTON potentiometer is mainly used to measure magnitude of unknown EMF compared with standard cell. So what is the main function of having a DC CROMPTON potentiometer? It is used to measure the magnitude of unknown EMF compared with the standard cell voltage. Now we will go with the constructional details of a DC CROMPTON potentiometer. DC CROMPTON potentiometer. What is the basic purpose of having this DC CROMPTON potentiometer? To measure the magnitude of unknown EMF by comparing it with the standard cell voltage. Coming to the construction. The construction of DC CROMPTON potentiometer will be like this. Rheostat, unknown EMF which is to be measured. This is nothing but a dial switch. And this is nothing but a slide wire. Dial wire. And this is nothing but what? Slide wire. Along with this, it consists of one more parameter, that is nothing but galvanometer, where the galvanometer is connected to a protective device, that is nothing but a protective resistance. Let me say the resistance offered by this some protective resistance is some RP, which is connected to a standard cell. Finally, I am taking the position of the standard cell here, and here again I am using a switch, where this switch can be either used to a standard cell position or the same switch is used to calculate the unknown EMF. This is the general construction of a DC CROMPTON potentiometer. The basic parts of a DC CROMPTON potentiometer are EMF E, which is to be measured, rheostat, dial wire, slide wire, galvanometer, protective resistance, standard cell, and unknown EMF, where the EMF is to be measured by using this DC CROMPTON potentiometer. So we need to follow certain properties before going to measure the magnitude of unknown EMF by using this DC CROMPTON potentiometer. You need to follow some properties before going to measure the magnitude of unknown EMF by using this word DC CROMPTON potentiometer. The first property is the dial wire, that is following steps. These are the following steps. How I need to measure the magnitude of unknown EMF by comparing it with the standard cell voltage. By comparing it with the standard cell voltage. The first step is dial wire and slide wire. Dial wire and slide wire, which is present in the DC CROMPTON potentiometer, is set to a standard cell voltage. Is set to a standard cell voltage. That is, if the standard cell voltage is taken as 1 volt, the position of dial wire and also slide wire is also set to the voltage of the standard cell voltage. If it is considered as 1 volt, then the voltage of this dial wire and slide wire should be considered as 1 volt. This is the first point. This is the first point. The dial wire and slide wire is set to a standard cell voltage. Coming to the next point. In order to measure the magnitude of unknown EMF. The next point is that the switch S, here this is considered as switch S. Here this is considered as switch S. Now the switch S, which is connected in the DC CROMPTON potentiometer, should be moved to the calibration position. Switch S should be moved for the calibration position. That is, it need to be connected to standard cell. It need to be connected to a standard cell. Why? Because here the switch is connected between two parameters. Either it can be connected to a standard cell, or else the same switch can be connected to calculate the unknown EMF of a cell. In the second step, I am going to use the switch S for the calibration position. That is, the switch S is directly connected to a standard cell here. Coming to the third point, here I am using a protective resistance before the galvanometer. Here I am using a protective resistance before the galvanometer. The main purpose of adding an element called protective resistance before the galvanometer is that to avoid the damages in the galvanometer. To avoid the damages in the galvanometer, I am using what? Protective resistance. I am using what? Protective resistance, which is given as Rp in the circuit. What is the main function of protective resistance? In order to avoid the damages in the galvanometer during initial stages. In order to avoid the damages of galvanometer during initial stages, I am using this protective resistance. What is the first point? Dial wire and slide wire is set to a standard cell voltage. What is the second point? The switch S should be connected to a standard cell voltage. That is, switch S is moved to a calibration position. Coming to the third wire, placing of a protective resistance in order to avoid the damage of what? Galvanometer in the initial stages. Now, coming to the next point, that is next step in order to measure the magnitude of an unknown EMF. Whenever the switch S is connected to a calibrate position, that is connected to a standard cell, the galvanometer which is connected will start deflecting. After certain period of time. Whenever the switch S is moved to the calibrate position, as it is connected to a standard cell, the galvanometer which is connected to this circuit will start deflecting. After certain period of time, the galvanometer will show the null deflection value. This indicates that the galvanometer is standardized. That is, the standardization of DC CROMPTON potentiometer is completed. When the galvanometer has been shown the null deflection value as which S is moved to the calibrate position. Now here I am using a protective resistance. So if I want to make use of a galvanometer to show the null deflection value, the protective resistance which is connected here will be short circuited. The protective resistance Before the galvanometer shows the null deflection value, the protective resistance which is connected before the galvanometer will get short circuited, and you are going to make the potentiometer a standardized one. Now the standardization of DC CROMPTON potentiometer is done. But what is the aim of using this DC CROMPTON potentiometer? To measure the magnitude of unknown EMF by comparing with the standard cell voltage. Now the standardization has been done with respect to the standard cell and galvanometer what I am using in this. Now what is my next step? I want to measure the unknown EMF. Now I want to measure what? Unknown EMF. Now the next step is that the switch S should be connected to unknown EMF points what is shown in the diagram. First switch S is moved to what? Standard cell voltage. Now the switch S is moved to what? Unknown EMF. Now I can calculate the unknown EMF by using setting of a slide wire. So by the standardization of a potentiometer, I am going to get the unknown EMF. Now this unknown EMF can be compared with the standard cell voltage. This is regarding the construction and working of a DC CROMPTON potentiometer. This is a procedure. What is the first point for standardization and also to calculate the unknown EMF? The dial wire and slide wire is set to a standard cell voltage. If the value of the standard cell voltage is 1 volt, the value of these two wires also should be set as 1 volt. Coming to the second position, the switch S should be connected to the standard cell voltage. That is, it should move to the calibrate position. For the deflection of a galvanometer. Coming to the third point, I am using a protective resistance before the galvanometer. What is the main function of protective resistance? In order to avoid the damages. In the galvanometer, I am using a protective resistance. So whenever the galvanometer shows the null deflection value, the protective resistance will be short circuited. And the standardization of potential will be completed. Once the standardization of potentiometer is achieved, it is easy to calculate the unknown EMF of a cell. So now the next step is switch S should be moved to the unknown EMF points, and by using the settings of a slide wire, I can calculate the unknown EMF by comparing with the standard cell. This is regarding what? Potentiometer and standardization. And in types of potentiometer, we have discussed about what? DC CROMPTON potentiometer, its construction, working, and what are the steps followed for the standardization and to calculate the unknown EMF in case of a DC CROMPTON potentiometer.